Slope-intercept form is the first of 3 linear equation forms that we're going to be looking at. It's the one that I think is the most useful, the most practical, the easiest to use. So what we're going to be doing with this is we're going to be writing and graphing linear equations using slope-intercept form. First, I want to talk about parent functions. You have a family of functions, and that's going to be a group with common characteristics, and then the parent function is the simplest function with these characteristics. So definitely want you to write this part right here, and let's take a look over here at some parent functions. You do not have to write all these over here. What I do request that you follow is, let's see here, okay, that you get this one right here, because that is the linear parent function. This whole chapter is about linear equations. We're going to look at absolute value graphs later. We'll look at quadratics later, and then once you get into algebra 2, pre-cal, things like that, you'll see radicals and cubics and cube roots. So when you have a linear equation, it's going to take the basic form of a line. It's odd, meaning that it's to the first power. So like if you look at this quadratic, it's to the second power, so it's an even. If this cubic here, it's an odd power because it's at the third power. The domain and the range, the x values and the y values. There is no limit to either of these. The x values go infinitely into the negatives, and they go infinitely into the positives. The y values, the range, goes infinitely into the negatives and infinitely into the positives. You can see the difference down here on this quadratic. Its domain, its x values go infinitely into the negatives and infinitely into the positives. However, the range is limited at 0. It does not go below 0. So that's what the deal is with the infinity symbols there. And the end behavior, that's nothing you have to know at this point, but as x is going to be approaching -0, x approaches, not -0. X approaches negative infinity, y approaches negative infinity as well. As your x value approaches infinity, your y value also approaches infinity. You just need to know the linear equation is going to look like a line. And these other ones, there'll be things that we look at later, and it will be useful for you to know the basic shape of those parent functions. This right here is slope-intercept form in this big box here, and I suggest in your notes that you write it rather large because it is a big deal. It is y equals mx plus b. Now if you think back to our last lesson on direct variation, it was y equals kx. Direct variation is basically slope-intercept form, except there is no y-intercept, because as you'll recall with direct variation, the y-intercept was 0. So if you had plus 0 there, that would just be dropped and simplified to mx. M is the slope, like on direct variation. K was the slope. It's represented by different letters because K is a special kind of slope because it only applies to direct variation. So here's an example of one with numbers actually in there. So the 3, since it is the coefficient for the x, it's the slope. So that would be a change of y of 3 and change of x of 1, 3 over 1, because that's equivalent to 3. The y-intercept is -5. So how that would look on a graph over here, 1, 2, 3, 4, 5, it's going to cross right here at -5, has a positive 3 over 1, up 3 over 1, up 3 over 1, oops, and so forth. And then I can draw my line. Let's get arrows on each end. And there's my line. Now you could also see how this would work into a table like what we saw before. The numbers that I have in there as far as x values, I have 0 in there. If I had put 0 in for x, if I put 0 in there, I'm going to have 3 times 0 minus 5. That would be 0 minus 5 would be -5. If I had put positive 1 in there, 3 times 1 is 3. 3 minus 5 is -2. and then I have a positive 2 there. So you see how these are falling on the graph. 3 times 2 is 6. 6 minus 5 is 1. So I'd have the coordinate 2, 1. If you think about how quickly I graphed that line, that was much more efficient than drawing this table. So if you have an equation in slope-intercept form, you can kind of bypass the table because you know the characteristics of the parent function, and you know that this is slope-intercept form. I need to start at the y-intercept, and then I just increase by going up 3 over 1, up 3 over 1. So let's look at writing that equation in slope-intercept form. This can be presented in a couple of different ways. First, from the key components, they give you the slope of 3 over 2, and they tell you the y-intercept is negative 1. Well, you can just put that into your slope-intercept form. Y equals, m is my slope, which is 3 over 2, so that would be 3 over 2 times x, and then my y-intercept is negative 1. I could put plus negative 1, but as we know, that can be simplified down to just minus 1. So there's that equation in slope-intercept form. If I'm trying to do that from a graph, I could use this example over here. I need those key components. I need slope, and I need the y-intercept. The slope here is, it has a change in y of negative 3, 1, 2, 3, and then it goes to the right, 1, 2, 3, 4. So that is down 3, right 4, which will be a slope of negative 3 over 4 because it's changing my y value, my rise, over the run. So that would be y equals negative 3 over 4 x. And then my y-intercept, that means it's crossing the y-axis at positive 3. So that would be plus 3 on the end of my equation there. Now, writing an equation from 2 points. So think about what pieces of information do we need? Well, if it's slope-intercept form, I need the slope and I need the y-intercept. And keep in mind that your y-intercept is 0 and whatever that y-intercept is. So first find the slope, and you do that by using the 2 points, and remember slope being change in y over change in x. Let's pick a different color up here. Let's go with blue. How about that? So I need 2 points. I didn't have those already on here. I'm just going to make up some points. How about that? I'm going to do 3, negative 1, and then I'm going to do 5, 4. Those will be my 2 points. So if I'm going to find the slope, that's going to be change in y over change in x. My y values are negative 1 and 4, so negative 1 minus 4 over my x values, 3 minus 5. Negative 1 minus 4 is negative 5 over 3 minus 5 is negative 2. So that's going to simplify down to 5 over 2. That's my slope. So m equals 5 over 2. Next is to find the y-intercept. And so what you would do then is you substitute the slope in one of the coordinates to solve for b. So I have the slope here, 5 over 2, and I'm going to pick one of the coordinates. And I'm going to pick 5 and 4 just so I'm not having to deal with negatives. So I'm starting with that equation. Y equals 5 over 2. Oh, and I'm sorry, I shouldn't have put y there. I should have put, what, oh me, that was way too big. What that coordinate was. Okay, so we're going to put 4 equals 5 over 2, and then times x, which is 5, plus b, because I'm wanting to solve for b. So I need to clean this part up here. That's going to be 25 over 2, so 4 equals 25 over 2, or you could have translated that to 12 and a half, plus b. Then I'm going to solve that by subtracting, and I'm going to go ahead and make that 12 and a half, just so it's easier to subtract over here. That's not real pretty, is it? Let's see if I can make some more room. Okay, there we go. So those will cancel because they're equivalent there. B equals 4 minus 12.5 would be, let me think about this, 8.5, yeah, it would be negative 8.5. So that'll be my y-intercept. And then the third step is to build that into my slope-intercept form. So y equals, the slope was 5 over 2 x minus 8.5. And I'm going to go ahead and put that back. Well, no, we'll leave it like this, 8.5. I could have turned it back into a fraction, but that definitely works like that. So probably if I would have had some coordinates already made up there, they would have been a little bit friendlier and not, you know, quite so decimally. Would have been more like whole numbers. Graphing a linear equation. We did this a couple of slides ago, and I like this acronym right here. Think of it as y equals mx plus b. M is what you move, and b is your beginning. And then you draw your line based on that. So here's the equation that we're going to graph. As you're doing this in your notes, you don't need the grid there. Just make sure you have an x and a y axis. Give yourself a few tick marks so that you can see where it is that you're starting. So my beginning is positive 4 as a y-intercept. And then I have a negative 3. So I'm going to go down 3, 1, 2, 3 over 1. Down 3 over 1. Down 3 over 1. Now I could also go up 3 but left 1, and then that would also be considered a negative because its left is a negative. And let's get our line going here. There we go. You want to extend it past your points just a little bit and then draw arrows on the ends of it to show that it extends infinitely in both directions.